And here we go. We are live. Hello, everyone. Good morning, good evening, good afternoon, wherever you're following us in the world, and welcome to the second episode of the Fika Words podcast. Together, we have a very, very special guest for our podcast, and myself, Andrea, and Adam, another guy working together with me at Fika Works, are very happy to give welcome to Sebastian Scheele from Kubernetes. Hi, Sebastian. How are you doing?
Hi, Sebastian.
Can you hear us? Maybe there are some troubles in the connection. It is always the live kind of thing.
The internet problems, yeah.
Internet problems. Here
Andrea?
It is.
Okay.
Yeah, we can hear you.
Perfect. Great to be on the podcast. Looking forward for the next hour to talk with you about operators and all about Kubernetes.
Indeed, Kubernetes, operators, Terraform, a lot of things to talk about today, a lot of interesting topic. We have Adam here, as I was saying before, together with us. He has been working with operators for quite some time. Right now, he has a great expertise around Kubernetes operators and how to deploy infrastructure in a way that it's maybe not the classical like Terraform infrastructure as a code way. And yeah, it would be super nice exchange to have both of you asking question and giving your opinion about different ways that we have to deploy infrastructure as a code using Terraform, using Kubernetes operator, and so on. The two approaches, at the end of the day, they are not exclusive, meaning that you don't need to go one way or the other. But yeah, it's always interesting to know how people are doing things and how we can solve the classical infrastructure problem that we have out there. I want to quickly remind all the people that are following us on YouTube that you can post your question in the chat. And whenever you feel like, whenever you have a topic, whenever you have a question for any of our guests, feel free to post it in the channel, feel free to post it in the comment section, and we will try to get back to you as soon as possible. First of all, Sebastian, do you want us to give us a quick introduction about yourself? I mean, you've been in the infrastructure world for a while, and I'm sure most of the people that are following us on the stream they actually know you for your big interest and big work in operators and cluster API and Kubernetes and so on. But yeah, can you give us just a couple of words about yourself and your interests?
Absolutely. So hi, I'm Sebastian, and originally studied computer science, then moved into a complete different direction, started working for SAP, implemented business software, so ERP, CRM, so completely something unrelated to infrastructure. But then inside of SAP, I moved into the HANA development, so database development, and there more and more infrastructure was coming up. And when then Docker were announced, and at that time, I also left SAP and started more developing on my own, and I really started to find it interesting. And so we had quite from the beginning of this challenge, how do I deploy this on multiple servers and not only to one server? And so when Google announced Kubernetes, I was immediately liking it, the idea to manage it and to have a tool which is completely built around Kubernetes. Around Docker. And so started Kubernetes as a company, more or less on the date, or on the months, 6 years ago, with the idea, we need to have something which can really scale and manage a lot of Kubernetes cluster. And that's what we built and did over the 6 years. I'm here CEO, responsible for the product development, but also for general strategy. But besides that, I'm also really actively on the community. So I'm in the governing board of the CNCF and the Linux Networking Foundation. One of the early things we did also was starting an own conference called Container Days. Hopefully, we'll do it in a hybrid mode and in person again this year in September, because it was also for us important that, how do we get the community together and how can we talk and exchange ideas? That's a bit about me.
Yeah, it's great. Indeed, very important to mention the Container Days conference. It's running from the 5th to the 7th of September, and the call for paper is open for another 5 days, folks. So in case you want to submit your talk, feel free to go on and submit this talk to this very nice conference where I've been already before. But yeah, as you were saying, your interest grew a little bit when you found out about Docker, when you found out about Kubernetes, and how you can use basically Kubernetes to automate your Docker deployments, basically your container deployments inside your infrastructure, right? But I know as well that you've been one of the early folks around operators in particular, but also cluster API, right? So you were one of the, let's say, like early adopters, I think we can define it, of operators and cluster API.
Yeah, so potentially going back in the history of Kubernetes. So when we started like working with Kubernetes 7 years ago, nobody really know where are the big challenges. And so what we saw quite fast at that time, only GKE was available as a managed offering. And so we saw with customers that they're struggling managing Kubernetes cluster. And then when we decided to start as a company, we were thinking about how can we make this more easier. And we said, hey, let's build an somehow orchestration engine for Kubernetes cluster. And then the question was like, what's the best way to manage this? And we came to the idea, we're talking to our customer and say, especially for microservices, Kubernetes is the best way to manage container infrastructure. Why can't we use Kubernetes itself to manage Kubernetes? And so at the beginning, we wrote some deployments and pods at that time to deploy the whole Kubernetes master on the Kubernetes cluster. And we saw, hey, that's somehow working. Can't we leveraging this control loop logic from Kubernetes itself to deploy this, to reconcile this, and do updates? And so, like, more or less 5.5, 6 years ago, when we really started with the first commits to Kubernetes, it was already the idea, let's build this control loop logic. At that time, there was no name for it, but now it's called operator. So having Go code to deploy and manage the whole lifecycle of your system. And one of the biggest challenge then was like, how can we manage the different providers, like talking to AWS, talking to Google, talking to VMware. And so we had it somehow baked in, but it never felt really like it's a great solution. And so we started with some guys from Asia, a project called KubeNode, starting like building this as an operator. And then we realized and get the information that Cluster API was kicking off. At that time, one of the contributors there was Google, and we had a meeting. I think it was KubeCon Seattle. And so we joined there together and shared our ideas. And then we said, oh yeah, let's bring some code base from what we have all to Cluster API and get this forward. And that's when we jumped onto the Cluster API, implementing the replicas, node replica set and machine replica set, machine deployment, and things like this.
And so on. I see. Yeah, very interesting. It's always nice to hear a little bit more of the background behind the business, background behind a certain idea, and so on, and how certain trends as well as born. But yeah, maybe Adam, can you give us like a bit of an overview about operators and Cluster API? Because I noticed that there might be somebody in the audience that has never used operators or has never used Cluster API. So of course we want to have them on board with us in the discussion. You have quite some experience with operators and Cluster API in particular. So you can give us like a high-level overview.
Yeah, I've been working with the operators pattern for the last 5 years or even 6 years now. So operators in general, it's in the Kubernetes world, it is a piece of software which has some operational knowledge about another services. So like in the case of the Kubernetes that Sebastian mentioned, their operators are aware how to actually deploy Kubernetes clusters, how to manage etcd instances, how to manage the whole control plane. So all of this, instead of writing some Ansible playbooks or whatever, you are putting this logic into the operator, which is another software which is running inside of the Kubernetes cluster. And this operator is then configured through the custom resources, which are the API server objects that you can deploy and define in the Kubernetes. And then, as Sebastian mentioned, there's reconciliation loops, which actually ensures that the state which is represented by the customer sources is actually reflected in the external system, which is in the case of Kubernetes is the Kubernetes cluster. Or it can be any other software, because there are existing multiple many of different type of operators. Like for MongoDB, you can find one. You can find one for the Prometheus, is a very old one operator that you can find in the Kubernetes ecosystem. So there's lots of those.
Yeah, makes a lot of sense. The idea behind operators at the end of the day is that instead of writing pages and pages of documentation about how to maintain, upgrade, and configure a certain software, we just try to code it in a way that is homogeneous, let's put it in this way, and where we try to code all our knowledge and the maintainers and the coders' knowledge into the operator that then defines how we are maintaining a certain software in its whole life cycle. And this is valid for like many tools out there, many open source tools like Prometheus, Grafana. Many of them have their own operators, but of course it can be applied even for a Kubernetes cluster. And these allows us a little bit to like delete all these little differences between GKE, EKS, and so on, and try to create a uniform platform.
Potentially to add this, I think what's really important, and where a lot of people only see the benefit of operator where the workload is also on Kubernetes is, technically there is no limitation. You can really leveraging the control loop and the Kubernetes API to manage tools which are not running on Kubernetes, as long as they have a decent API you can talk to. So I think the majority of operators which are out there, like the MongoDB or Prometheus operator, is also deploying the workload on top of a Kubernetes cluster, but that don't needs to be the default. You can build, for example, in cluster API, build operators which talk to the cloud providers and spinning up VMs, and at the end, more or less everything which you can control over APIs, you can manage by operators.
That's true, indeed. There is also a tool that is getting quite a lot of traction lately called Crossplane. Have you ever heard of that, Sebastian? Do you have any opinion about it? Also, Adam, yeah.
Yeah, absolutely. We heard about it. It's a CSF. We also tried it, and it's a CSF project. It's definitely really interesting how you can leveraging operators to manage other resources. But it's not only Crossplane. There are also like dedicated operators from AWS to manage resources on their platform. I think Google and Azure has some similar things so that you can manage this. And I think this is, I hope this will become more popular also in the future, because then you can end-to-end manage your whole infrastructure based on Kubernetes principles.
Yeah, indeed. Let me play the devil's advocate here for a second, okay? Let's just try to ask the tough question, or let's put it in this way. Very often we see, especially in our infrastructure, as Kubernetes being seen as the thing that will solve all your problems. What's a common critic? The criticism sometimes that comes from the outset is that we should try to get away from like this idea of let's try to manage everything inside Kubernetes, and rather use like different tool for different purposes. So it's very common, for example, at the moment to say, okay, I spin my whole infrastructure using Terraform. So using Terraform, I define my Kubernetes cluster, my databases, my Redis, and so on. And then I use something like operators or just plain Helm, let's put it in this way, to manage what is actually running inside my Kubernetes cluster. So a lot of people seem still to, like the idea of using the operators for everything that involves Kubernetes only. What is your answer to this idea, and why do you think the trend? And also, what trend do you see out there?
I think there's no black and white. I think both ways have their pros and cons. I think it's important to really look into what you want to achieve. Also, what knowledge do you have in-house? Are the existing operators available you easily can adapt, or do you need to build operators? Because that's definitely much more challenging than if something is available. And I mean, in general, I would say, as for every tool, you really need to first ask from a more business perspective, what are really the business problems I want to solve, and how could my architecture and solution look like? I think Kubernetes can do a lot of stuff and can help to harmonize a lot of stuff. But I think it's true as same for microservice. Microservice is not the solution for all problems in the world. There are enough cases where you want to have a monolith, and as distributed systems brings a lot of complexity, you need to know and you should have this decision that you need to manage then this complexity. And for Kubernetes, for example, you're pushing down a lot of complexity into the networking layer. And if you are not used to it, potentially your architecture or the debugging gets much more complicated, and you are not so familiar as when you would run it as a monolith application on one machine. I mean, it depends on the workload. It depends on so many facts. And I think having this possibility to choose and saying, okay, I can go that way, but I also can do it one way. I think it's really the nice way, because as more and more different tools you're using, as more knowledge you need to have. And if someone says, okay, I really want to concentrate my whole organization, my whole skills on focusing on the Kubernetes style, why not go this way? If someone says, oh no, I have already so much knowledge in Terraform, Ansible, and other tooling, I want to keep this. Yes, I think it's also a way. And then later you can consider, do you want to later potentially migrate, or do you want to stick for this architecture?
Yeah, I see your point. Not having like a black and white view. It's very helpful in this case. What was your experience, Adam, with building operators, for example? Like, you've been doing it for quite a while. Do you think like the environment around operators is mature enough? Do you find the right documentation and all these kind of things? What was the experience? What are like the kind of suggestion that you have for our audience in case tomorrow they decide they want to write their own operator? Let's put it this way.
Let me start with maybe something which is contradictory what you just said, but do not write your own operators, and you really need to write one. I mean, right now there is so much of the operators which are available in the market, like for example the ones that were mentioned for provisioning the infrastructure, for managing the databases, managing the different applications such as Kafka or whatever is up there. So you should only write your own operator unless you have a very good use case or business case for it. Because otherwise you will just invest resources into writing a very complex piece of software, because you need to put all the operational aspect of your product or all of your service that you want to operate on. So that's definitely something to keep in mind. Then if you decided that you think that you really need one operator, then there's a bunch of the tools that you can definitely leverage that will make your life easier to build one from scratch. Like, you have the frameworks which can already scaffold the whole code for you. So you will be only responsible for putting the reconciliation logic, which is the main operational logic that you will be touching your services and other or managing products. So that's it.
And when do you see this switch happening? When do you see like, okay, when you start encountering this particular situation, this is probably when you should start building your own operator, for example?
Well, that's if you have like if you already have like set of the operator that you tested and they do not solve the problem for you, then you can consider writing your own. But for example, when I was working for the big corporation, they have a lot of the custom internal services. So in that case, there is nothing off the shelf that you can find in the market that will actually fulfill all the requirements. So this is a good use case to actually go and try to build your own tooling around those services, so you can leverage the whole benefit, all the benefits of the Kubernetes, such as the API centrism, the custom resources which come with all the all the methods out of the box. So then you can actually start considering that these problems can be solved by applying this operator pattern and developing your own tool.
I see. There is a question by Piotr. We just got it on our YouTube chat, and yeah, it's for both of you actually. Which Kubernetes operator framework would you recommend to build the operator? We know that you can build your operator in with different frameworks already, but also with different languages. That's also something I would be curious to hear about, especially also from Sebastian. If you see which kind of adoption do you see out there? Do you see people writing their own operators or not? And in the case the answer is yes, like which kind of tool do they use to build their own custom operator?
So I'm fully with Adam. So before you're starting writing your own operator, you should definitely look into what's outside there already. I would even go one step further. If you find some operator for your application, but potentially not fully satisfying you, contribute to upstream instead of building a second, third, or whatever version of it. Because if you solve it once and contribute to the community, you will participate, but also the community will participate. I mean, from the operators outside, I think the majority is will in and go. But it depends also what language and knowledge you have in-house. So I know people who are building it in Java and Python. We internally, when we start, there were no frameworks there. The only framework was the Kubernetes repository. And so we said, okay, then let's start with Go and leveraging and vendor the specific parts from Kubernetes we can reuse. But yeah, that's also, I think, where most of the operators are written. And as there are different frameworks like Kube Builder or operator framework, I think it depends on the cases. We internally use mostly Kube Builder, but I think there are also others who are using operator framework. I think there are even more.
Yeah, indeed. So depends mainly on the language that you prefer to use. One more question for you, Sebastian, still regarding operators in general. What's next? I mean, what's the next step? What's currently the main struggle with Kubernetes and Kubernetes operator? Do you see any improvement on how operators will be in the future? What do you see as the next big thing?
I think one of the biggest challenges, if you want to run different versions of an operator on the same cluster, it gets tricky, sure. Especially if they have different CRD types. So if you have changes in the CRD types, it's more or less not possible to do this because the CRD types are global and not namespaced. You cannot easily do this. And so if you involving your operator, the easiest way currently is managing and running them into different clusters. That's also a way how we from Kubernetes running a lot of small Kubernetes cluster instead of a few big Kubernetes cluster, because this helps you to mitigate these problems on operator, but in general also on how to manage Kubernetes cluster, how to manage a life cycle of Kubernetes cluster. Different teams can then can have different update strategies and things like this. To mitigate this, or what we're seeing, especially with like larger corporations, is a lot of the organization really want to go into a self-service driven Kubernetes API driven service deployment, so that you can provide Mongo as a service, Postgres as a service, and that you have a common API layer you can use for this, and this is called the Kubernetes API. And to solve this problem, I think there's upstream currently some work done on KCP to have a lot of different like virtual Kubernetes cluster, so that you can mitigate this problem. Okay, I have different resource types and things like this, but share them and run them all on a Kubernetes cluster.
Yeah, indeed. This is actually a problem that I faced very recently, where we have a deployment for a client where we have like a very outdated version of an operator. And, like I'm talking about like years outdated kind of version of the operator. And upgrading it to the latest one, it's tricky because, or you go and you do like each one of the upgrades, like version by version, and you see what happens. But you cannot just say, okay, let me just run a second version of the operator on the same cluster, because all the CRDs, as you just mentioned, are in common. You cannot just say, okay, let me just another version of the operator, or we just experiment with that and just go from one version to the next, to the latest one. This becomes indeed really tricky with operators.
And I think this is really, this is what you see on like really the advanced operators, that they take care about this life cycle, so how you upgrade, and more on the basic operators, you need to take care. And I think that's also one thing which will come more and more, that your operators are smart enough and knowing how to upgrade and what versions you can upgrade and things like this, that you're not running into this conflict, and that okay, how can I go the chain up from one version to the next version.
Yeah, indeed.
Yeah, just to add, because this is exactly what Sebastian just said, that the most recent Kubernetes version in the CRDs, they implement something conversion webhook, so you can actually have multiple versions of the same CRDs, and the operator should be responsible for doing the conversion between the outdated version to the newest one. So your end user can still like apply the old version, but your operator will take care to make sure that the outdated version is the outdated CR is transformed into the newest one and persisted in the etcd. So that's something that the community took care of, but still it requires some additional work from the operator's developer, and not all of the operators are doing it right now. So still some manual work needs to be done in that.
Okay. So this is something that already exists in the current version of Kubernetes, but it's something that needs also to be implemented on the operator side, if I understood correctly, right?
Yeah, that's a webhook that you the operators developers needs to put into their software.
Okay, interesting. I didn't know about that. Very interesting point.
But it has also its limitations. So if you have completely like if you have version 1 and version 2, which are completely not compatible to each other, and you cannot upgrade, then you are in a deadlock, and you still have this problem. So there are more and more capabilities. You can do this, but still it's not solving all the problems. So it's really like you need to be a bit careful what you're doing there, especially if you're running stateful workloads, to not destroy your stateful applications.
Yeah, indeed. You don't want to do that, right?
Yeah.
We prefer to avoid that. Makes sense. And do you in general see this trend, like amongst the client that you have? I mean, you have a lot of experience in the sector, and you know a lot of clients that are using Kubernetes already. Do you see this trend maybe towards for which company do you see this? Do you see this operators approach being more used more? For example, do you see, like, for example, I don't know, like startups tend to be a little bit more pushing toward this kind of approach, or rather enterprise and so on? Do you see like a trend in here, or it's more of a mixed thing?
I think on the one side, startups adapting it faster because they are much more used to or having this SRE / DevOps knowledge much more built in, and this you build it, you run it. When we started, this was a big thing. You build it, you're running. In enterprise organization, it's still hard, and they will, I think, not really getting to you build it, you run it. They're still having this, okay, I have my database department, I have my development team, and in that case it makes also sense because not every team should be partly experienced of an database, you really need experts in this and group them in a team to really become really deep experts. But the question is, how do they expose the services? And that's where I think the big enterprises currently more looking into it, that it's not like they expose their services via a ticket-based approach. You need to create a ticket or an email to get access to a database. That it's really like a service-based approach. So you can, similar as you can create an RDS or an EC2 instance on AWS, you can request your services via an API. And there, I think the big enterprises really start seeing the benefit of having an operator and leveraging this. On the one side, as it's much more automated to automate more stuff, and on the other side, to exposing this also future-wise more to external people. And not like internal other groups in the organization.
I see. Yeah, that explains a lot. We have another question from YouTube that I actually find very interesting from Xiwen, and this is for both of you, Sebastian and Adam. Can't an operator leverage tools like Terraform or Ansible under the hood, or is this considered to be an anti-pattern? What do you think about that, Sebastian?
I think that there are already solutions out there. I think there's a tool called Terraform, which is exactly doing it. And I think crossplay, what we talked about in the last release, they build up an integration to Terraform to leveraging at least the API to do this. I'm not so in detail about Ansible, but there are tools around there. The question is, how close both get, or like how much workarounds do you need to do to really get the things together, or is it less, or is it much easier to build it completely from scratch instead of building workarounds around this to get this work?
What do you think, Adam? Have you ever used this kind of Terraform Ansible under the hood for your operators, or you prefer to just code them directly?
Well, I'm not a big fan of this approach, because those tools are their objective is quite different from the operator. So Terraform, if you use for provisioning of the infrastructure, you are doing this like you're not doing this in the loop most of the time. Most of the time you have some sort of the CI/CD pipelines that just execute and deploy in the push model the infrastructure. So that's not something that fits the operator pattern, because the operator pattern is constantly watching the resources and trying to reflect the changes which are part of the resources into the infrastructure or into the external systems. So this is kind of like mixing two different paradigms into the tool. So not a big fan of it. So I would not do it. I would just use these tools as they were designed for. So Terraform in the CI/CD pipelines, and Ansible also in some sort of the DevOps pipelines.
Let's see, thank you, Adam. There is also another question about Xiwen that is quite interesting, that says CRDs, so custom resource definition, and operators go hand in hand, as we've also said before. Do you see CRDs becoming an integral part of an operator, like CRDs managed by the operator? I understand that CRD is a requirement right now, perhaps a topic for Kubernetes special interest group, something like that. Yeah, what's the relationship between CRDs and the operators? Why they're important? Why they're needed? And as Xiwen is asking, should they be managed by the operator itself or not? What do you think about that, Sebastian?
I mean, as you said, CRDs are integrated part of operators. So at least what I know, all operators are built around CRDs. The question from my perspective is much more like, what in the future more the abstraction layer on top of it? Do you need to expose all the details to, for example, the next end users or things like this? Or do we need in the future things like, for example, for the operation team, the database operation team, they get a much bigger CRD, or they get more CRDs, and the end user or the developer who's consuming the database have a less complex CRD. For example, they can only upgrade the versions, but cannot manage the CPU and memory quotas and things like this. But in general, yes, without CRDs, our operators are not possible. And I think there are even discussion in upstream Kubernetes to build to change the built-in functions like pods and things like this, future-wise also to CRDs, but I don't know if they're still continuing this. I heard there was some discussion in the future. Does it make sense to go that way? But I think really the power of operators were really when it started building CRDs. And there was a quite interesting thing before CRDs are available. There was something called third-party resources, which started to bring up this logic. But when they were invented, some of the features were missing, and so there was a need to completely refactor it and coming up with custom resource definitions.
Very interesting idea, this one of having sort of maybe the same resource with a subset of the settings for the developers and having the full CRDs, for example, for the people maintaining the infrastructure and so on. This is also a very discussed topic, right? I mean, very often we hear people saying, okay, how much access should I give to the developers to my Kubernetes cluster? Should developers even know that there is Kubernetes under the hood or not? Where is the line, and where do you see this? Where do you see the split between having a CRD for developers, having a CRD for infrastructure? How much developers should know about Kubernetes in order to work with it? What's your opinion on that, Sebastian?
I mean, in best case, depending on how we define a developer, but let's assume it's a application developer. He should, from my perspective, focusing on the business problems the application should solve, and don't need to understand all the bits and pieces inside of the underlying infrastructure. I mean, who is a deep expert of the Linux kernel? You don't know. You don't need to be to get the system running. And I think, or at least I hope, that will be also some of the features in Kubernetes, that there will be abstractions layers on top, and depending on what you are building, you can go quite deep into it. So you can go up to the deepest level of Kubernetes APIs, but you don't need to, so that it's easier to consume and things like this. But I think it will take a bit more time to really go coming to that point, that we have good abstractions for different use cases, for different personas inside of the organization, that they get their APIs as it is required.
Indeed, I see. Although what I see sometimes is that people say, well, I mean, if you're a developer and you are writing software that, we can put it between brackets like cloud native software, let's put it this way, you should, know a little bit about Kubernetes, at least the basics. I'm not talking about all the internals or things like that, but at least have an idea of, how your software is containerized and might work inside the Kubernetes or a cloud native infrastructure, and have an idea how these services can communicate with each other, especially when you're working with microservices. Do you think this statement is true, or would you adjust it? Do you think developers should have at least a basic understanding of tools like Kubernetes and so on, or it's the task of the infrastructure team to try to keep the abstraction as much as possible?
I mean, as we're talking about distributed system, and you have a lot of services who are communicating to each other, I think it's definitely good to have at least a basic understanding how communication flows and things like this, because otherwise, especially if you have cross-service problems, it gets hard to debug your problems, and then the infrastructure team, for example, they are not so aware of your services, and it definitely can help to mitigate or optimize your services across different microservices. And the question is like where you really need to draw the line, and how deep you want to go. And I think it really also depends on the interest of the developer. I know some are really want to understand every bits and piece. Others are more like want to understands a high level, but then focusing more, for example, on their specific services.
I see. Yeah, indeed. Sometimes it's difficult to draw the line, and I guess, correct me if I'm wrong, that it also depends a little bit on the business, on the company. You have businesses where, as you said, you have like these big silos, and you have like developers, infrastructure, database administrator, and so on. And instead, you have other businesses that are where, especially like when you're working in a startup, like smaller amount of team, and everybody does everything, kind of thing, correct? So everybody knows a little bit of everything.
Exactly. I think it really depends also on the size and how your organization is structured. I mean, we're still working with a lot of enterprises where you even don't get automatic access to firewalls and things like this. And then it's hard to automate this because the internal rules need an Excel sheet or a ticket to create this. But in a startup environment, you don't have everywhere this expert. So everyone needs to be a bit more like hands-on and understand roughly all the different pieces. And when it comes to problems, specific people need to really jump into and at least try to go as deep as possible to fix or debug the problem so that you can get a fix.
Indeed, you made me remember of a story that I had of a friend who was working for a company. It was like, well, it's very difficult in here because every time you want to open a port or you want, to set like a firewall rule, you need to go through 100 different tickets and, talk with a lot of different people, security team and so on. And so he finally decided to run his MySQL database on port 80 because it was the only one open. Of course, this is not something that should happen, but the idea is that this should, highlight that there is something going wrong inside the company in terms of communication, that the communication should be improved, that the process should be made a little bit more easy. Let's put it in this way. Piotr is asking a question that is also related to this, related to management and companies and how the Kubernetes adoption inside the companies, in particular the Kubernetes operator pattern inside companies is adopted. Piotr is asking, how do you combine high-level management to follow the Kubernetes operator patterns instead of Terraform, Ansible, etc.?
I mean, I think, first of all, it depends a little bit how technical they are.
Sure.
One benefit is definitely what Adam explained, this reconciling logic, comparing to Terraform and Ansible, where it's a push logic. You make a push it, because with the reconciler logic, when something happens in the night and it's not working anymore, the operator picks this up and tries to repair this based on their state and the state machine, what it has inside. And so with this, in best case, in the night, you don't get even an alarm that something is not working. In case of Terraform or Ansible, depending on how you have it automated or you need to build automation around this, in worst case, you get an alarm and then somebody needs to manually re-execute it because there was no push of a new change. It's only getting the system back into the state as it was described before. And so I think that's really a powerful thing to say, hey, this can help you also to save resources or to make the operation much more smoother, because with this, nobody typically needs to be called in the night or things like this because something goes wrong. Your operator will fix this. And so your team can focusing much more in involving your application, involving your operator to cover much more cases, instead of fixing again and again similar things based on a runbook or based on things like this. And especially on real complex applications, like databases where you need, for example, have built-in capabilities to scale up, scale down, automatically backups and things like this. I think there it gets really hard to achieve this with Terraform and Ansible completely in an automated way, that you can say, hey, scale my database from 3 to 5 replicas, and then automatically it knows all the different things and execute multiple steps to do this. Of course, it's possible, but I think this really complex things. It's much more easier to build this in a decent programming language where you can do much more things instead of building something around with Terraform and Ansible. But as I said before, it really depends also on the use cases.
Yeah, indeed. I mean, using operators at the end of the day is a very nice way of getting the knowledge from the maintainers, the knowledge from all the community coded into a piece of software. That's at the end of the day the idea behind operators, having the knowledge about upgrading, scaling up, scaling down, especially for pieces of software like databases, as you mentioned, that can be, tricky to upgrade, running multiple replicas, read-only replicas, write-only, or things like that. One thing that I guess some people might be afraid of, when you use, let's imagine you start using Kubernetes today, and like you take like an introduction workshop or something like that. You have a couple of days around Kubernetes, and you already need to learn so much to get your feet wet. Okay, you need to learn about pods, you need to learn about services, ingresses, different types of ingresses, different types of deployment, stateful set, daemon set, and so on. And when you ask these people, okay, why don't you use an operator, for example, to run your MySQL database? They might think, well, I mean, I have already like my Helm chart that works quite fine. And, adding an operator on top might be an abstraction that I don't really need. And at the end of the day, what I will end up doing is just I will have not only like MySQL to upgrade, but now I will have to upgrade the operator from MySQL and MySQL itself. I'm taking MySQL as just an example in this case. What do you answer in this case? What would be your answer to this worried developer?
I mean, you bring up a quite valid point. The initial learning curve is quite high. First to get into Kubernetes, and then also to get into the whole operator concept. And I think it's also well, it depends a bit, but like start slowly, like not like, okay, you have here now do Kubernetes, do operators, do service mesh additional, and 20 more things. So I think it depends every time what are the use cases, and I think there's nothing wrong to start, for example, with your MySQL in an Helm charts. But when it really comes to production, I think at a certain time you really should think about, okay, how do I automate this? And what are my requirements? Do I need backups? Do I need to have scale this? And then it gets like definitely really complex to solve this with Helm charts, because then you build like scripts around this and things like this to say, and then it's potentially easier to say, okay, yes, from a dev environment, from a test environment, where I don't have high SLAs or guarantees on my database, I don't care so much as long as I have a storage underneath, the database is coming up again, it's working, potentially it's an easy way to start. When you bring it to production, it really depends. If you really need to have 99.999 availability, potentially, then it's definitely the right time to think about how can I much more automate this, and what do I do in case of disaster? So in case of service goes down, who is fixing this, and how is then my backup strategy working? What do I do when I get much more traffic during the day? How easily can I scale my database, scale up, scale down, things like this? And then I think when you have these questions, it's definitely the right time to look into operators. If you feel comfortable before and you say, okay, now I'm doing so much with Kubernetes, let's dig into it earlier. Of course, I think you can do this earlier as well. But as you said, the learning curve at the beginning is quite high. And I think that it's also sometimes, which is forgotten or a bit ignored from people who are really experienced with Kubernetes, because you know what deployment services, ingress, and all these different kinds. You know how operators and the control loop is, and if you once understand the logic, like in most IT systems, then it's easy, and then it's like, what's the problem? Bring an operator in this. But before you really understand this logic, I think it's really important to understand this and going step by step.
Indeed, I think a lot of people are also, worried about the blast radius as well. You upgrade your operator, for example, and something happens, your operator reacts in a way that you didn't expect, or maybe there is a bug in the operator or things like that, and all of a sudden everything that has been deployed by the operator doesn't work anymore, or it's broken, or you need to restore it somehow. Is it something that is it like something people should really worry about, or is like more of a kind of worry that's maybe not so it doesn't have any foundation really?
I mean, I think it really depends on the operators. I think they are in the community or general, they are really advanced operators where also a lot of automated testing is done and the quality is really, really high. But there are also a lot of operators potentially who are not at this stage, and where definitely would try different use cases. In general, I would follow with my operators also the same follow like dev stage production as you do with the normal development. And as our software is built that way, I'm definitely a big advocate to running a lot of smaller clusters and trying to solve like having namespaced solution, because then you, as you said, it's harder to test than different version and on the same time. So if you have capabilities on the cloud provider or using solutions like ours, where you easily can spin up a lot of Kubernetes cluster with small footprint, do this, because then you easily can test. You can have developments, and you can start with upgrading your operators on the development, see if things are working or not. You can do the same on staging. If you really want to be sure, set up a dedicated staging environment, test everything there out, and going that way.
I have another nice question from YouTube, from Piotr, asking, what is your favorite operator? And this is for the both of you, Sebastian and Adam.
So Adam, you can go first.
I like external DNS, for example. Yes, compared to operators in that case. Yeah, external DNS is the favorite mine.
I mean, to be completely honest, of course, Kubernetes platform as an operator to manage Kubernetes cluster. As a second one, definitely also work around cluster API. So that's definitely my favorite operators.
Indeed, let's talk a little bit about cluster API. We mentioned it very briefly at the beginning, but it's a very interesting and a very new topic, right? So cluster API, basically, just for the audience, spending a couple of words on it for the audience in case you're not familiar with it. It's a way to define in a declarative way a set of clusters that you want to create, a set of Kubernetes cluster. It's a project that is relatively new. Correct me if I'm wrong, Sebastian. And I would like to hear what's your experience with it. I mean, do you use it? I know that you have been working with it for quite some time now. Do you consider it production ready, for example?
As I said, we were one of the first contributors to it. We heavily using it, especially the machine part of the cluster API. So all of our clusters and all machines we are managing are based on it. And it really gives us a scale to automate the whole lifecycle of your worker nodes. The benefit is you have a generic API. You can talk to different providers. Doesn't matter if it's a big hyperscalers or on-prem. And the really nice feature is that you can then build high-level services on top of it. So there is this autoscaler for cluster API. So it doesn't matter if you are on the hyperscaler or not. If your platform have autoscalers or scale groups, with this, you can do this everywhere. You can do this on-premise, on VMware, OpenStack, but you can even do this with, if you have enough bare metal machines and scale up and scale down a cluster based on requirements. And I think that's really a really interesting part of cluster API, and where you can see how this APIs can build up higher level services and can provide you more capabilities.
Which is like the situation in which you would say, well, go for cluster API is like a perfect fit for this use case. In which case would you say that?
I mean, it depends which cluster API is now since end of last year in a beta state, which means the APIs are stable and will not change. I think it depends, first of all, what providers you want to go for, because they are different implementation, and the different providers have a different level of maturity. So some they are definitely production ready, some are really early stage. So I definitely would to look into what stage and what maturity they have. Also depends on what flexibility do you use. For example, if you're on the hyperscaler, does GKE or EKS or AKS provide you enough? Do you need to have more? Do you want to run your own control planes, your own cluster to manage it? And I think it really depends there what requirements and what flexibility you need.
I see. There is a question from Katalin from our YouTube chat that asks, multi-tenancy and operators, what if I can't migrate all namespaces at the same time? I think, Sebastian, your solution was to create multiple clusters at this time, right? So create like a different cluster with different version of the operators, if I understood it right.
Yeah, exactly. I mean, if you have like this huge clusters, you have every time this challenge, not only with operators, but also with deprecation of Kubernetes APIs, which comes more common nowadays. That, for example, beta or alpha version get removed. And if you have a lot of teams on the same cluster, you first need to be ensure that all of the namespaces and all of the applications have migrated so that you can upgrade clusters. And same applies for operators. And if you have like more smaller clusters, it's much easier to achieve to orchestrate also inside of your organization. If you need to have like this big project to upgrade your Kubernetes cluster again and again, I think the problem we are solving on a higher level on the application side, that every team as independently can deploy and manage the application. You push down into the infrastructure layer, and then you're back to this two upgrade cycles, Christmas and Easter a year. If every team has flexibility on their own or every application, I mean, it depends a little bit how you structure it and how do you need it for your business case. You have much more possibilities. Some teams can go every time with latest, greatest version of Kubernetes. Other teams are staying, for example, on a quite old version because they say my application is developed to the end. I only do bug fixing and I only upgrade Kubernetes cluster when there's when I need to upgrade because of a security fix, and then slowly upgrading. And these are conflicts, and with a lot of small clusters, you can mitigate this. With a few big clusters, it's hard to achieve, and a lot of project management around which you try to avoid, at least initially.
Yeah, and I guess that for the people that are worried about how the hell do I manage like 1,000 different small cluster, your answer would be, well, cluster API. Am I right?
Our answer would be Kubernetes platform.
Yeah. Well, okay. I mean, it's also an open source software, so it's super nice, and it's also interesting. I would be also connected to the question that we have on screen. How do you build a business around like an open source software like Kubernetes? And I also would be curious to hear, was it the idea from the beginning to have Kubernetes open source? Because if I recall correctly, it was not open source from the beginning, but it became open source. Is that correct?
Yeah, that's correct. I mean, we are every time really engaged on open source contribution. So if you're looking into the statistics of the Kubernetes project, in the last 3 years, we are, I think, in the top 10 of the contributors to upstream Kubernetes, even before big companies. We had also a lot of parts open source, but our core was not open source. And
okay.
Now I need to think about, I think 2 years ago, roughly, we decided, okay, let's change this. Let's also follow with our product a much more open core strategy and make the core open source, and some enterprise features will go into the enterprise version.
Was it a difficult decision to take? What was like the thought process that pushed you into going into this direction? I can imagine that like you build a company around the software that you're selling. Okay, your software is not open source, so that software is basically the source of revenue for your company. Was it a difficult or like a challenging decision to say, you know what, right now we want to follow more like an open source approach. We would like to open source this software, and how did you decide, okay, we should make this feature open source, this feature not open source, and so on?
I mean, open sourcing the core was every time an option for us. What we saw is that we get more and more traction, and we have another cool tool called Kube1, because we had every time this chicken egg problem. Kubernetes is an operator, but what you need for an operator is a Kubernetes cluster. And so quite at the beginning, we realized, how do we get the initial Kubernetes cluster? And so we tried several ways, but after I think 2 years or something like this, we said, okay, we have all the building blocks to build this. Instead of trying around with other tools, let's combine this and ramping up a single Kubernetes cluster. And that was the idea of Kube1. And there we were clear from the beginning, it will be open source. It was open source from the first day on. And when we decided to make Kubernetes itself open source, we looked into what are typically enterprise features you would need, and also how the easiest way to describe how we cut it is like in the open source version, you can manage with one installation more or less one region or one data center. So you can, for example, manage one region on AWS or one region on GCP or one data center on VMware. If you really want to have this umbrella view across all your different environments, you have a lot of different providers and things like this. That's in the enterprise version. And now we're adding things like metering. So, for example, that we collecting the usage information of all the different cluster, and so that you can use this for your internal billing, for example, or advanced rollout of policies like OPA policies. That's only possible in the enterprise version. The core is completely workable and survives, like I would say, the majority of the use case, especially of small organizations. And the enterprise version is then really tied to like classical enterprise needs.
I see. Any challenge that you didn't expect, like when you open sourced Kubernetes and all these other tools? Anything that you said, okay, I didn't see this coming, or something like that?
Not that I didn't see this coming, but one challenge is definitely all the different open source licenses. I mean, we had this for because we used a lot.
Yeah.
But then it's also it was quite clear we use Apache, but what impact it has, what do we need to consider, where do we need to draw clear the line, and things like this. So in general, I think one of the biggest challenge in open source is licensing, and also how people understand open source, I would say, because majority of the people, as long as your code is on GitHub, think it's open source, which I would say partly. The source code is open, but for example, if you don't provide like binaries to run this and you have your whole build logic like hidden and magic, yes, you can access the code, but if it's a really complex application, what do you gain out of it? Without enterprise or without paying for it, you cannot really leveraging it. So I think it's really like also interesting to look into license. What license are compatible with your license? So with each PR, we're checking if it's not violating our allowed licenses. If we have licenses So we have licenses which are definitely blacklisted. We have licenses where you can request or developers can request a specific approval, but then we need to ensure first what we are doing with it. Is it potentially complicated? And that's quite some effort and quite complex.
I see. And another question I would be curious to hear is how do you, I mean, right now you have several people working at Kubernetes, some software developers, some more in consulting, I guess, and so on. I'm interested in particular in the developers of the platform. How do you split their time between open source and, creating and growing the community, taking care of the pull requests coming from the open source community and so on, and building the actual, business feature, so the feature that will go instead in your enterprise solution?
Yeah, I mean, we typically first, in general, doesn't make a big difference if you're looking external or PRs coming from external versus internal. Look into and review PRs because that's blocking people. I mean, it depends, of course, a bit how high the priority is on our roadmap. Even if there's an external contribution and it's high on the priority, people will jump definitely much faster on it when also internal something that has a low priority. So that's definitely the case, and there is no golden rule or something like that. We say, okay, we dedicated X amount of time into it. Our developers are actively on our Slack, on GitHub, and we don't try to make a big difference between what's coming from us, what's coming from the community. Really trying to be fast on things and typically PR first and then writing own code. But I think it's not really so much also about writing the code. It's also, as we leveraging a lot of external dependencies, like what's the best way to integrate this, like with writing as less code as possible, so that the whole code base keeps maintainable, keeps clean, and what tools do we integrate? How do we integrate this? How do we maintain this? All this kind of questions.
So in general, you could say that you're pretty happy that you brought Kubernetes to. I mean, you made the Kubernetes open source. What would be your recommendation for another founder maybe out there that is currently considering open sourcing the code base of its own company?
I think it's important to understand, okay, how do you make money out of it? I think there are different ways to do this. As we selling more or less software and our customers are running it, we following an open core strategy. Others are providing their software completely open source, but providing then a SaaS offering, a complete managed offering of the solution. And I think that's one of the things you should consider quite early at the beginning, because potentially based on this, also some architectural decisions needs to be made, and it's later potentially hard to change this again. And so having there a good understanding, also what license you want to use, GPL, Apache, MIT, whatever. It's definitely important to consider, and then building a community and trying to get traction on the open source version so that it gets adapted more and more.
But I guess you can say that. Sorry, go on, Adam.
I just wanted to ask a question. Sebastian, are you not afraid that some big player will come and will fork your open source code base and start to do another offering on top of it? Or do you secure yourself somehow from this kind of, let's call it, attack from the big players?
I mean, that was our initial concern, why we said, okay, let's keep this closed source. At a certain time, we realized, yes, if some of the big players will adopt it, it will be much more like a gift for us, because then our solution will get a lot of traction, and So we are not really afraid about it. I think that it's really like, okay, what's your value proposition on top of it, and how can you still build a company around this? I think our solution don't have this problem that companies like MongoDB or Elastic, that the big cloud providers will take this and run this as a core business because they have all a Kubernetes offering, a managed Kubernetes offering, and so I think it's really then if some big players adapting it, where it's your value proposition and what you can do better, and what knowledge you have in-house. Because at the end, yes, they can throw a lot of resources on it, but are they really open to do this, and what's their core positioning on it?
We have a question from the audience saying that from Boris, asking, on top of what you said about people still learning Kubernetes, do you recommend to actually focus on operators? Terraform seems to have a larger demand in the market, at least for now. Indeed, very often right now, when you look at job posting and so on, it's always mentioned like Terraform and Kubernetes, and I see, for example, much less, for example, like Kubernetes and operators, just saying. What's your thought on this?
I mean, when I really see job offerings who are looking for Kubernetes operator, it's really about building operator, which typically is much more complex. And I think a lot of people who are deep into Kubernetes also have decent knowledge about Terraform or can jump into it quite quickly. If you have a general understanding of Kubernetes, like how deployments and things like this, deploying and managing operators, I think is also not so hard. The question is like, okay, when it's time to really jump into developing operators, and they are definitely, it has, depending on where you're coming from. If you're coming from development, it's easier to learn. If you're coming from classical admin side and are not so used to development, then you first really get into the development, and then the learning curve could be even higher. But I think I would not do either or. I would more looking into like having decent understanding of both, because I think both should belong to your tool stack, and you should have a decent understanding. If they use an existing infrastructure or want to do some stuff with Terraform, you're not saying, oh no, I can only do this with operator, vice versa. If they want to use operators, you heavily and only saying, okay, let's do it with Terraform because you only have the knowledge in Terraform.
Yeah, indeed. I can recommend to the audience to follow the Operator SDK Quick Start Guide. It's a very nice resource to get started with operators, and start from scratch. Start from the basic the fundamentals behind operators before going in and building your own operators. And your first operator is going to wipe out everything, so just don't worry about that. It's part of the process. Let's put it in this way. We might have a couple of more questions about from the audience, I think, if we can have them on screen. But otherwise, Adam, do you have here we go. Another question from Piotr. Where do you see Kubernetes and the cluster API in 5 years? It's if I would know the answer to this question, I mean, you can try to predict it, but yeah.
Yeah, exactly. That's a good question. I mean, going back, how old is Kubernetes now? 6-7 years potentially. So, I mean, if you see how the whole ecosystem changed in the last 5 years, I think it's really hard to predict. I mean, where I want to see Kubernetes, we definitely want to be a big player in the market and still growing, becoming even more international. Currently, we are in 24 countries, so looking to add more points and on the map. I hope Cluster API will be an integrated or not integrated important part of how you manage Kubernetes cluster in the future, and so that we all can agree on a default way, not only how to manage deployments, but also how to manage the lifecycle of clusters itself.
Yeah, very good point. Very good point. What do you think about tools like, before we talked about Terraform in particular, but there are a couple of new tools on the market to define infrastructure, to define infrastructure code. Tools like, for example, the CDK, the Cloud Development Kit. What do you think about these tools? Or Pulumi, it has been also like pretty popular lately. Do you have a thought on those? Have you ever used them?
Not so much, as we are doing our stuff mostly with Kubernetes operator. I think I'm biased, and as we wrote all of our code base in Go, so I think it's a natural choice for us. I think they definitely are good to have. The interesting part will be what will be later, or what tools will be survive, and what will be not existing in 1 or 2 years anymore, because there were also like things like what was it, CaseNet, for example, which is not maintained anymore, and so what are the tools which will be out there in the future, which will stay for long, which are currently potentially hyped, or but the adoption will be low. So I think it will be interesting to see, but I think the good thing is that having a choice really push the market, brings new innovations, and brings also innovations to existing tools. It's not like that the whole market is staying and you need to survive with what's available.
Indeed. Yeah, very good. Very good answer about that. Recently working with CDK, and it's an interesting experience, put it this way. Okay, I think we have no more question, and we are over 1 hour, 1 hour 20 now. So I would say that we can close this episode here. Thank you very much, both Adam and of course Sebastian, for joining the episode. It's been a pleasure. To have this nice chat with both of you about Kubernetes, operators, Terraform, cluster API. We mentioned so many different things, but it has been a super nice and interesting talk. Very nice to have you here, Sebastian. Let's remind our audience that if they want to check out Kubernetes, they can, of course, check it out on the official website. And your conference, Container Days, is running in September. As we were mentioning before, the call for paper is still open for a couple of days. So go and submit that call for paper, folks. With that said, thank you to both of you. Thank you, Sebastian, on behalf of FikaWorks, for joining us during this episode. And I hope to see you soon. And who knows, maybe we'll shake each other's hands at KubeCon this time in person and not virtually.
Yeah, thanks for the invite, and also thanks for the audience. If you have further questions, feel free to add me on LinkedIn. Happy to exchange. Hopefully we can see us all in KubeCon.
Perfect. Have a nice day, everyone. And goodbye. See you
Bye.
next episode.